Hello, my name is Asya Kamsky. I'm a principal engineer with MongoDB. I want to tell you about what's new in MQL in version 4.4, but of course I also want to tell you how powerful MongoDB query language has been all along. Now, remember this quote, aggregation pipeline is the coolest feature of the MongoDB query language. Well, turns out I'm the one that says that, and I work with aggregation pipeline a lot. A couple of years ago at MongoDB World, I gave a talk about the power of the aggregation pipeline to analyze your data right where it already lives. I'm going to give a quick 5-minute recap of that talk for those of you who missed it, and also for those of you who want to understand the very basics of the aggregation pipeline and how it works. Now, we talked about a lot of things in this talk. If you want to hear the entire thing, recordings are available, plus the code that I used is still in GitHub. But for now, here's a recap. The purpose of databases is to store data and to retrieve data. Now, if you know exactly how you'll retrieve data, that's great, but sometimes you have to reshape the data and do some kind of analytics and answer questions about whether your app was successful or why it was unsuccessful. Now, if you could anticipate it, you could pre-aggregate your data, but we don't have a crystal ball, so we also could aggregate that data elsewhere. And usually when we say elsewhere, we mean some kind of analytics database or Hadoop cluster or something like that. But I say you should aggregate the data right in MongoDB. And the reason is, it's the same as every analogy that I like. If you need to cut a piece of wood, you don't want to drive all the way to the big box store and all the way back just because they can cut it in 0.2 seconds with their super expensive saw. Instead, you can cut it with that garage sale $2 saw, and maybe it'll take 5 minutes, but it saves you a very long round trip. Sounds familiar? We want to save that long round trip also when we're sending our data somewhere, right? Moving the data means money and time. Now, what is aggregation pipeline where we want to move this data? Well, it's not a pipe like a pipe, and it's not even like an oil pipe, although that's a little similar. It's really most like the Unix command line pipe. Now, I spent a lot of time on Unix command line. I hope some of you do too. Aggregation pipeline is kind of similar. Basically, documents go through a pipeline. They go through a bunch of stages, and documents come into a stage, documents come out of a stage, they feed into the next stage, all the way until you have a result. Now, we kind of represented the pipeline as a train, and each carriage is a stage. Now, where do documents come from to go into the pipeline? Well, it turns out that they come from either a collection, or they might come from a view, which is just an aggregation pipeline on top of another collection. And there are also some special stages, like system stages, that return documents that you could then transform with the aggregation pipeline. At the end, you have more documents. Now, here's an example pipeline. Here, we have 3 documents that we start with, right? And I'm going to put those documents through a number of different stages. First, we're going to match. Now, these are books, and I'm going to match only the books where language is English. So only 2 out of 3 documents pass through that stage. Unwind means we're going to unwrap the array and kind of flatten the documents. So if a document had 3 array elements, we're going to get as a result 3 documents. A document that had an array of 2 will output 2 documents. So we now have 5 documents. Now we're going to group them, and we're going to group by subject and count how many books there are on each subject. So now we end up with 4 different subjects with different counts, and now we can do things like sort, maybe in descending order, maybe limit, transform, project. There's all kinds of stages that are available here, but that's the gist of it. Now, I like to say that stages can be thought of as having different effect on the documents that are going into it and coming out of, right? Some stages will decrease the number of documents that pass through it, like match will only pass through the documents that match a condition. Limit specifies explicitly, right, how many documents should go through. Things like sort They don't change the number of documents, and they don't change the shape of documents, but they reorder them. Sort doesn't change the number of documents coming in or coming out, nor does it change the content of documents, but it can reorder them. So I'll put them in a different order that they come in. There are other stages that transform the documents, can add fields to them, remove fields, etc. Now, one thing that I explained was that you can extensively use the explain feature, and that is to understand and see exactly what is happening under the hood. So if you run an aggregation with a number of different stages, explain can show you that under the hood, different number of stages may be happening. For example, we combine sort and limit together so that we can more efficiently sort, keeping only the top three, right? We sometimes reorder stages like match and unwind here to put match as early as possible in the pipeline so that we can use an index, and more detailed explain can actually show you which indexes are being used, etc., etc. Now, one important concept that I touched upon is blocking versus streaming stages. Let's look at just the top document, the Great Gatsby. You can see that we can tell how it should go through the first stage and the second stage. We don't need to wait for the rest of the documents, but once we get to group, we really can't proceed any further because we don't know what the count will be for each subject once we've seen all of the documents. So that makes group and sort stages what we call blocking stages, meaning that they can't proceed with any output until they've seen all of the incoming documents. And we talk about resource usage. Now, streaming stages use much less resources than blocking stages because we take a batch of documents and we just pass them through all the way to the result. When you ask for more results, like the next batch, the rest of them go. What happens if there's a blocking stage is, as you can see, all of the documents must arrive at the blocking stage before any of them can proceed. Something good to keep in mind about performance. Now, we also talked about expressions. Now, expressions are these operators that you can use inside of your stages to do multiple transformations to all of your fields. Now, expressions can be kind of divided into things that have to do with math or strings or transforming schema or logic. The ones that I focused on the most are the ones that have to do with arrays. The reason is that if you don't have any arrays in your data, you might not even be using a document database, right? If your data was completely flat, you might have just considered using a tabular database. So arrays are very powerful. An aggregation pipeline has an incredibly powerful way of transforming these arrays. I showed a bunch of examples of all the different array expressions and how you can do very powerful transformations. We showed some examples, some readability tips. And then I showed a really fancy example about network suspect activity detection, which was inspired by something a customer of ours wanted to use aggregation pipeline for. And that is, given a collection where they just had flat records, each one was user ID, IP address they came in from, and a timestamp. And for a given time period, let's say 3 months, they wanted to know, did any user log in from more than one IP address within a 10-minute window? So a little bit of a windowing function type query. So they wanted an output that looked something like this, right? This user had these logins that are suspect. So within 4.8 minutes or 8.3 minutes, they logged in from these 2 different IP addresses. And this was the pipeline. Now, this looks really complicated maybe, but I promise you during that session, everyone could follow it. The code is still in GitHub, and you can find a recording where I walk step by step through how we construct this pipeline. So we worked to understand the stages in the best order for performance, why we want to check explain, looked at a lot of examples, and also had some tips about using functions for readability and reusability. And there's the GitHub repo where that code still lives. Now, we also talked about the future of aggregation, and we're going to talk about these things kind of as we march forward through time. So back we go, not quite to the present, but just to the following year, 2018. And in 2018, we debuted in MongoDB Compass which is a GUI, a graphical interface for exploring your data in MongoDB, it added functionality called the aggregation pipeline builder, which allows you to iteratively, stage by stage, to debug your aggregations and kind of see what's going on. It helps you with some completions, lets you save the pipeline and export it to your code. All great. Now, since then, we've also added a similar type of aggregation pipeline builder to the Atlas UI, where in addition to browsing your data, you can also build these aggregations. Marching on through time, we saw a whole lot of other things happen. In particular, last year, we did a lot of work to unify different languages and provide you more options for output. Now, when I say unify different languages, what do I mean? Well, let's say you have the sample document, and in that document, let's say this represents people, and there's an array called children. So maybe these are the children of the person that the document represents. It has a name, date of birth, and a Boolean depending, take two. And the array has a name, date of birth, and then a field representing whether the person is a dependent or not. So true means the child is considered a dependent, false means they're not. And in aggregation, you can do some pretty cool things, like you can create a new field called numChildren and use the size expression to get the size of the children array. You could also create a field called numDependents and use that same size expression wrapped around the filter expression, which takes an array and only passes through the elements that pass the condition provided. So if dependent is true, it's passed through. So here, the number of dependents would be 2, number of children would be 3. Great, fantastic. What about find? Can you use these expressions in find? And yes, as of 3.6, which was quite a while ago, you could use $expr to get access to every single aggregation expression in your query predicate. So here you say, give me all the documents where the size of the array of dependents is less than 2. Well, what about update? Now in update, you can also use $expr on the predicate where you say, I would like to update the documents where, and you say any element true means if there's any true elements, and then you have a map expression which gives you back an array only of the children where date of birth is before January 22nd, 1997, and dependent is set to true. And based on that, you're going to set some field audit true. You go, well, that's great, but that's not really using aggregation and update, is it? And I go, well, yeah, true. That was very sneaky of me to claim that. But it turns out that in 4.2, we made another incredible update to the update command. So the update command, a quick rehash, consists of 3 parts: the query part, the update part, and the options. Query part says which documents you want to update. That's unchanged. Options say things like multi-true or upsert true. That's unchanged. The update part is where you specify how you want to transform the document that you're updating. And before 4.2, that update had to be a document, and that document had one of 2 formats. Either it had a bunch of fields started with a $sign, which meant they were update modifiers, set, increment, push, add to set, etc. Or they were just field and value pairs, which meant it was a full document replacement. The good news is in 4.2 and 4.4, the subdocument syntax is exactly the same. It is unchanged. However, if you pass an array as the update, that means you're passing an aggregation pipeline, and that means that you can use the aggregation pipeline language to specify how you want to transform these documents. Wow, aggregation pipeline and updates, that's pretty powerful. Now, you don't quite get the whole pipeline, right? We don't give you access to all the stages. We only give you access to some of the stages, and they are all the ones that do one-to-one transformations. So for every document that's coming in, one document is coming out, which makes sense because you're doing this transformation to change a document in place, basically. So the three stages you can use are add fields, which we've aliased $set, so you could use either one. Project for exclusion, which a lot simpler, you could write as $unset, and then an array of fields you want to unset. And replace root, which you can use its alias replace with just a full new document specification. Inside of these stages, you have access to all of the aggregation expressions. So let's look at a quick example. Let's say that we wanted to update a document with ID 1 and increment field A by 1. If the document didn't exist, we wanted to create it. If these were on the left our documents that we started with, on the right would be the documents that the update would create. So if the field A didn't exist, it would be like incrementing 0, 10 becomes 11, 100 becomes 101. When the document didn't exist, we created, and then A becomes 1 again. And the last document, when A is not a number, you get an error because it says, hey, we can't increment something that's not a number. Now, we can do the same thing with the aggregation pipeline syntax, right? Brackets say this is an aggregation, and we say $set A to sum of the contents of A and 1. Same result here, same result here, same result everywhere, except the last one. In the last one, we get a 1 because $sum is an aggregation expression that ignores non-numeric values. If we wanted it to give an error, same as a regular update, we could use $add. $add will be very pedantic and only expect numbers that it could do addition with. So you say, well, that's great, but that's more or less the same. Why would I use this? I say, well, what if the business users say now, hey, when somebody is getting this thing in A increment, let's say A represents a score. If score is incremented for the first time ever, can we start them with 20 instead of 0? And you go, oh, I think so. I think that I can have a conditional, right? Because aggregation has a conditional statement. And if a certain condition is true, meaning if they don't have any score yet, then we're going to treat it like they had 20. Otherwise, we just do a regular increment. So we can check for type of A, and in the current document on the left, if the type of A is missing, then we're going to give them 21 points, or we could have just added whatever it was that they wanted to add to 20. Otherwise, we add 1 to the value of A. Well, of course, the business users come back and they go, well, we also decided that we want to cap everybody at 100. So once they get to 100, they can't increment anymore. Well, that's no problem. I'm just going to wrap this conditions that I already have in $min, where you get whatever's less, 100 or your actual score. And now they say, well, okay, we also would like to know what the previous score was whenever you increment the score. You go, no problem. I'm just going to add another field that I'm going to set called previous A, and it's going to get the value of A. And you can see that if the value of A was missing, then previous A is also missing. But when it was not a number, that's the value that gets stored in previous A. That's pretty cool. Here's another example. Let's say you decide that you want fields A, B, or C to always be set in a particular data set you have. So if A or B are missing, you want to set them to 0. And if C is missing, you want to set it to unset. And this is your data when you start. You can see every document has 2 out of these 3 fields. The third one would need to be set to the default. So we do an update with multi-true. And we can use a replace with stage with merge objects. And merge objects would take 2 objects. One would be the defaults, A0, B0, C unset. And the second object would be $root, meaning the existing document. And the nice thing about merge objects is that if a field occurs in multiple objects, the one that comes in last wins. Which means that if $root already has the value of A set, then it'll stay that. And if it doesn't, it'll get set to 0. So here is the result of this update, exactly as we wanted. Pretty handy. So unifying different languages, not only could you do an update with expression in the predicate, but you could also now have aggregation expressions in the update portion. For example, you could set a new field called num dependents that are too old, right? And that would be size of that same expression that checks which of the children were born before a certain date and set as dependents true. Pretty cool. So updates can be specified with an aggregation pipeline, and all fields from the existing document can be accessed. So you can have complex logic right there in that single atomic update. Now, it might be slightly slower, but it's a lot more powerful. Now, more options for output were added as well. Now, some of you might know that we've had the ability to output results of an aggregation to another collection since all the way back in 2.6. So this is something that you might hear called as, poor man's materialized view. You run an aggregation, it outputs some result, and you just put that into some new collection. The only thing is there were a few restrictions on that. One is this new collection had to be unsharded, and if it already existed, it would get completely overwritten by the new result. So you had to rerun the entire aggregation to get an updated result. In 4.2, we added a new merge stage to the aggregation pipeline. And merge is pretty powerful because it allows you to output the result of your pipeline into an already existing collection and specify how you want it merged with the documents that are already there. This collection that you're outputting to can already exist. It can be in the same or different database, and it can be sharded. So let's look at the syntax. Merge requires that you specify where the result goes into, and then you could just give a collection name, or you can specify the full document with document name and the collection name. And that's the only field that's required. Other fields all have defaults. For example, the on field says which fields determine whether a document is the same for the purpose of merging. Now, by default, we're going to assume in an unsharded collection that underscore ID is that field. In a sharded collection, it's a combination of underscore ID and your shard key value. But you can specify your own combination of fields. The only requirement is this combination of fields must be unique. Now, actions, once you know how to merge documents, you kind of have two paths you can go, right? If the new incoming document didn't match anything in the new target collection, well, usually you want to insert it. And that's actually what we picked as the default action. If a document is matched, you could see how you might want a couple of different things. You might want to replace the old document with a new one, or you might want to update it so that the new document will be a combination of existing fields and new incoming fields from your aggregation. What we did is kind of equivalent to an upsert, right? It's an update where new fields are going to get added to existing fields. And if nothing is there, then it'll be inserted. So when not matched, the default is insert, but there's a couple of other actions available. You could choose to discard. So when there is no match, you could discard the document, or you could fail or essentially raise an alert and abort the aggregation. When matched, if merge is not the action you want, you could choose to replace. You could choose to keep existing, meaning ignore the new document. You could fail, or if you specify an array, it means that you're providing a custom pipeline. So you can specify a custom aggregation pipeline to describe what actions should be taken with the new incoming document and the existing document in the collection. In other words, how they should be combined. A real simple example might look very similar to what we already saw in expressions and update, where you might say add fields or set, and then you'll say set the field called total in the document that already exists, and make it a sum of $total, which is the existing value of the field, And $new.total refers to the total field from the incoming document. In other words, one that's coming out of this aggregation. Now, merge can take a let, and let can define parameters, arguments, like you could name a particular field something based on the existing incoming document. By default, without you saying anything, we define new to be a variable that refers to the entire incoming document. So $prefixed fields are in the existing document, and $new prefix fields that are incoming. Pretty powerful. Let's look at a couple of quick examples. The first example is we have some data coming in, and before we actually add it to our cleansed, validated data, we put it into a temp collection, and then we run some kind of an aggregation on it to make sure everything is valid. And at the end of aggregation, we want to append it to the new collection. So that pipeline to massage, cleanse, and check that data could be anything you want. And then you just say merge into data. When matched fail means that if a document that you're trying to insert matches an existing document, something is wrong because you're not supposed to process the same data more than once. This is maybe a little similar to SQL, insert into a table, select something from another table, which could be a very complex select. Kind of the same thing here. Another example might be how you would populate roll-ups into a summary table from a table or collection that has raw details. So let's say that we have registrations collection, and every time somebody registers for an event, we write into there the event name, the date, and some other information. What I want is a summary collection that just has daily roll-ups for each event. So for each event date combination, I want it to be unique and to just have a total to show me how many people registered. So if I want to create these new entries in the existing roll-up table for event MDB 20, let's say the .live event, I can match all of the registrations for that event, group them by date, count them, use project to reshape them into the field names that I want, and then merge into reg summary, merging on the combination of event and date. And if I run that, let's say on May 2nd, it's going to populate all of the dates all the way up to May 2nd. And let's say we're early in the morning of May 2nd, there's only been a handful of registrations. Now, if I want to rerun a pipeline later on, just for incrementally since the last full day that I ran this, what I might do is now say, okay, match the same event only for date May 2nd. So after midnight, May 2nd, and before midnight, May 3rd, get the total, and now set the other two fields and merge that in. And assuming that we're, let's say, after midnight, this might be the full total for the second. Now, we could also do this for a range of dates by saying, well, give me everything that's greater than midnight on May 2nd, group by date again and total, set the fields into the shape that I want, and merge them in. And then we'll incrementally be able to add these totals without having to rerun the entire aggregation on the entire raw source collection. Wow, that's a lot, but did 4.4 add even more? Well, of course it did. If it didn't, why would we even be here? We've continued unifying languages. What does that mean? Well, remember how we had that array of children in the people collection? And we could aggregate and add new fields. But if you were doing a find, could you do the same thing? Well, in 4.4, you can. In 4.4, all of the aggregation expressions are available in find projection. Well, that's pretty cool. What else? Well, we've also unified find and aggregate sort. Now, you might know that in aggregation, if sort takes up more than 100 megabytes of memory, you can tell it that it's allowed to spill to disk. That option didn't used to be available with find. It is now. There's now an allow disk use option with find. We've also unified aggregation and MapReduce. Now, whoa, hold up a second, some of you might be saying. What is this MapReduce? You haven't even told me about it, and already you're taking it away? Isn't that slow JavaScript something, something, something? And I say to that, no worries. If you don't know what MapReduce is in MongoDB, you don't need to learn it. If you already have MapReduce jobs in MongoDB in 4.4, they will continue running exactly the same as they did before. But under the hood, they're actually going to be running as an aggregate pipeline. Yep. And what we did to make that possible is we added a couple of very powerful capabilities to the aggregation pipeline to be able to execute JavaScript functions. Now, you say, do I have to write this MapReduce thing to use JavaScript functions? No, you can use these custom expressions kind of as they are. And those two new expressions are accumulator and function. Now, accumulator is an expression that you use with group and group-like bucket, bucket auto, right? So when you're grouping things, accumulator receives values from every document, and you can define in a JavaScript function what it is that it will do with it. $function can actually be used anywhere that you have an expression. My colleague Katya recorded several excellent demos showing many examples for all of these new expressions, including accumulator and function. For example, showing how function can be used to turn some kind of a source URL coming from who knows where into an encoded URL using JavaScript built-in encode URI function. For accumulators, she demonstrates how you can create an average computation, but using a JavaScript function rather than using our built-in average expression. Now, of course, you wouldn't be using custom functions for something that you can do with our expressions, but I imagine that if you have much more complex computation to do that JavaScript natively supports, but for some reason aggregation hasn't added support for yet, this would be a great option. Now, remember all those expressions that I showed a few years back right at the beginning of this talk? Well, there's over 100 of them here, and we've been adding to them over the last few years, in every version, of course. We added a lot of conversion expressions and string manipulation expressions in 4.0. 4.2 added a lot of math expressions, as well as the ability to get current time or cluster time, and some additional regex expressions. 4.4 added, of course, accumulator and function, and a whole bunch of other expressions, all of which Katya demos in her demonstration. Which brings us to a new stage that we added in 4.4, and that is union. Union is powerful in that it allows you to combine output from multiple pipelines. So it could be from multiple collections, multiple pipelines on collections, and you can merge them at any point. An example that Katya showed is one that combines multiple collections that all represent the exact same data, but each for a different month. So rather than writing multiple pipelines, multiple aggregations that combine the result, you can write a single aggregation that pulls in data from multiple collections. Now I want to show you one of my favorite features of the new aggregation pipeline in 4.4, and that is detailed explain. Now, I told you before that explain is how you can easily see how the pipeline is actually being executed in terms of the plan. So execution plan says, well, I'm planning on combining these stages and then running that stage and maybe swap these two stages around. But execution stats on aggregation, starting with 4.4, give you more information in that now, in addition to showing you whether an index is used, how it's used, how many documents are going to be fetched, as you go through stages, it actually shows you how many documents are moving from each stage to the next stage and how long execution of that stage took altogether. Now, when you run this explain, it's going to take as long as the pipeline takes, but this is milliseconds, so not too long. So it shows that we had 78,000 documents go into group, but at the end, the group returned 3 documents, and this was total execution time. So it took 200 some odd milliseconds to get the documents, 262 to group them together, and then we reshaped the field, only kept the first 5 in the array, so the number of documents didn't change. That took another 200. No, wait, that's cumulative. So that's 214 seconds. That's 262 seconds total. So additionally, not that many. This one is basically negligible by comparison. And same thing with the sort, and that's because we were sorting only 3 fields. And that is an explain in aggregation 4.4. I hope you enjoyed learning about the aggregation pipeline, what's new in recent versions, and all the powerful things that you can do with MQL, find, update, and aggregate. Thanks for coming, and we'll see you next time.